Welcome to Agrointel, an AI-assisted agriculture decision dashboard. In one place, we combine production, yield, and market prices, so a farmer can decide what to plant, when to sell, and how to schedule sowing and harvest. The problem is that critical decisions rely on scattered data. Prices are volatile, yield varies by region, season, and timing. Mistakes are costly. Farmers and FPOs need a single simple view answers that answers these three questions. Are our yields on track versus the region? What price should we plan for next year and how uncertain is it? Which crops are safer and more profitable? And when exactly we should sow and harvest. For this prototype, we use a consolidated Excel workbook that we prepared for the app. It contains long-run records, area, year, state, crop, season, area, production, yield, min-max, model price, price per ton, and estimated revenue. We merged multiple official tables into one clean sheet so the dashboard can filter and compute KPIs in real time without joining several files. This normalized file is what the backend loads at startup. We applied straightforward, transparent pre-processing so the results are explainable, header normalization, type cohesion, derived metrics, text cleanup, missing values, outliers, aggregation readiness.
This is the dashboard we have developed. So let's start by understanding the filters at the top of the dashboard. So you can change the year range from 2015 to 2023, and we'll select the state as Tamil Nadu. And for the crops, we'll go with the rice. And for the season, you can choose a Kharif or Rabi. Now we'll go with all. So, and lastly, if you want to include a price for forecast, you can click this and apply. And this is the apply option. You can click on it, and you can see the changes made in this visualizations. So the first visualization is the predicted yield versus the benchmark. So this is a GAR chart that shows the predicted yield for the next season and compares it with the regional benchmark. For example, the rice in Tamil Nadu, the predicted yield is 2.79, so which is 0.11 above the regional benchmark. So the green color indicates a positive prediction and the red area would indicate below average performance. So moving on to the next visualization, the price outlook. This line chart shows the trend of the average price per ton over the years 2015 to 2023. The 95% uncertainty interval is represented as the shaded area, including price volatility. So by clicking this, we can see the price uh, outlook with 95% uncertainty. So, for example, in 2018, as you can see, we see a significant drop in the prices, and after that, the prices began to rise again, which is important for understanding the price risk in future areas. Next is the risk return by crop visualization. So this chart compares the expected revenue against the price risk for each crop. So for instance, we have seen that the cotton has a higher expected revenue, but also has a high price risk, while pulses and sugarcane are in the low risk areas. So the category which it returns with the stable return. So the size of the bubble represents the area under cultivation, which gives an idea of the crop's sales. So the next one is the state and crop revenue heat map. So in this heat map, we can analyze the revenue per crop across different states. Each cell represents the revenue generated from a crop in a particular state, with the color intensity indicating the level of revenue. So, for example, Tamil Nadu shows a strong revenue for pulses and for rice, as indicated by the darker red cells. This heat map helps identify which crop has historically performed best in each state. So the next visualization is a bar chart which shows the top five crops for the next year. So this shows the expected revenue for the top five crops for the upcoming season. For example, based on the analysis, rice has the highest expected revenue followed by maize and cotton. This helps farmers prioritize the most profitable crops to grow for the next season. Lastly, we have the season timeline, sowing and harvest, which uses a bar chart to show the sowing and harvest windows for different crops. The chart shows which months each crop should be sown and harvested. For example, for kharif crops are generally sown in June and harvested by October. And while rabi crops are typically sown in October and harvested in March. And this timeline helps farmers plan their planting and harvesting schedules effectively, ensuring they align with the optimal season. So, we have come to the end of the dashboard. So as we change the filters, the visualizations dynamically update based on the state, the crop, and the season and the year selected. So this gives us the personalized insights for each selection. So for instance, selecting rice in Tamil Nadu and filtering for Kharif seasons will show us the predicted yield, price trends, revenue comparisons, and the season timing specific to that region and crop. So you can explore and interact with each chart by clicking the details button in each chart, in each chart's header for more in-depth insights. Thank you.
This dashboard uses simple, explainable logic. For yield, we take production divided by area. If fertilizer uses high, we add a small uplift. We compare this for the regional benchmark. For price, we fit a straight line trend on yearly prices. The shaded band is a 95% confidence range. This return compares expected revenue to price volatility. Top left crops are safer and more rewarding. Top 5 crops are ranked by forecast price multiplied by expected yield multiplied by area baseline. Season timeline shows showing the team and the responsibilities. Here's our team and who did what. Abhimanyu handled data merging, KPIs, and the report. Alan built the front end with Plotly and the details view. And Hariharan built the Node and Express APIs, forecasting, and packaging. Our mentor, Ms. Shanbagaman, guided the agronomy framing and validation. I will shortly talk about the challenges faced. So we faced four main challenges. First, many header variations. We solved this with a robust mapping layer. Second, missing and noisy numbers. We kept nulls and handled them safely. Third, price spikes. We kept them and showed uncertainty in the price band. Fourth, speed with Excel. We kept endpoints lightweight so charts stay responsive. Talking about the future improvements that can be done. Firstly, we will host it as a website with saved presets and login page. Secondly, we will add weather and soil APIs to adjust yields and risk. Thirdly, we will bring live market prices and threshold alerts. Furthermore, we will add SMS or WhatsApp advisories for spikes and sowing windows. Lastly, we'll support multiple languages and one-click PDF or PNG exports. References and stack. Our stack is very simple and transparent. For the front-end charts, we use Plotly. For back-end, we use Express in Node. And to parse Excel, we used Sheet.js. Uh, so all these keeps it lightweight, explainable, and ready to host.